Okay, so this one's about chemical reactions and the things that are going to affect a chemical reaction and how they occur at different rates. Okay, and when you're thinking about chemical reactions and rates, think about cooking, because a lot of the things that would increase the chemical reaction time or decrease the chemical reaction time are similar to cooking. Which of the following would increase the rate at which a chemical reaction proceeds? A, grinding a solid reactant into a powder. B, lowering the temperature of one reactant. Okay, would you lower the temperature if you wanted it to cook faster? No, you wouldn't, so we know that one's wrong. Decreasing the concentration of the reactants. No, you wouldn't decrease them. Removing a catalyst. A catalyst speeds up a chemical reaction. In it itself is not used up in the chemical reaction, but it can cause the reaction to occur faster rate. So the correct answer is A, grinding a solid reactant into a powder. It's like taking a T-bone steak and chopping it up so it'll cook faster. Identify the combination of factors that will most likely increase the rate of a chemical reaction. A, decreasing the temperature. Again, it's like cooking. I want it to go faster. I'm going to increase the temperature, which means you're going to get rid of A and you're going to get rid of B. So we're at C, increasing temperature using a large block of the solid and stirring. Wait a minute, didn't we just say that if you chop it up, it's better? So C is wrong. D, increasing the temperature, chopping up the solid block and stirring. There you go. All those things are going to increase the rate, increase how fast a chemical reaction happens. When two chemicals react, their molecules must collide with each other with enough energy to make the reaction occur. Which of the following will increase the rate of collision between the molecules? A, increasing the size of the reactants. B, increasing the temperature of the reactants. Wait a minute. We don't want to increase the size because that would be like using a large block. If I decrease the surface area, that means less is exposed, so you don't want to do that. So C is out. Decreasing the volume, not going to make a difference. Increasing the temperature, there you go. Anytime you increase the temperature, there's going to be more collisions. Yeast is a single-celled organism to make bread dough rise. When yeast and sugar are dissolved in water and added to bread dough, the yeast cells use the sugar as food and in the process release carbon dioxide gas, which creates gas pockets in the bread. Which of the following could a baker do to make bread dough rise faster? Okay, number one, if you dissolve it in cold water, it's not going to work. Ask me. When I try to cook, it's like an adventure in cooking. Dissolving the yeast in warm water, actually this is true. I actually microwave my water to make it lukewarm, not hot. Put the yeast in the dough without the water, nope, it won't work. Add milk, won't work. You're going to need to dissolve the yeast in warm water. Okay. Increasing the temperature, concentration, and surface area of the reactants in a chemical reaction will cause an increase in the rate of reaction because the molecules will, A, be brought closer together. Well, yeah, that makes sense because if I'm closer together, I can react more. Okay, I can react faster and I'm going to be able to react more. There you go. Correct answer is A. In an automobile engine, gasoline and air are compressed by a piston in a cylinder. This forces the gasoline and the air mixture into a smaller space, bringing their molecules close enough to react. A spark from a spark plug then ignites the gasoline and air mixture, causing combustion. Which of the following factors cause the rate of combustion to increase? Okay, what do you guys think? Well, we know that if we increase the temperature, it causes everything else to increase. So, logic says anytime we're going to increase the temperature, we're going to have an increasing rate of combustion. There you go, guys. A metal iron reacts with oxygen in the air to produce the compound iron oxide or rust. What effect will painting an iron gate have on the rate of the rusting reaction? Okay, so I'm painting the gate. Can the air react with the iron readily? No, it can't. Right? So paint is going to act as an inhibitor. It's going to slow the chance of a reaction happening. Okay? So B, paint will decrease the reaction rate. This is why if paint gets scratched off your car, if you live somewhere where it rains, it rusts. The rate of a certain reaction doubles every 10 degrees Celsius increase in temperature. Which of the following would be true of this reaction? A, the particles of the reactants are increasing in size. Can they increase in size? No. Doesn't make sense. The particles of the reactants are losing energy. We don't lose energy. We conserve energy. But number two, we're increasing the temperature, so no, that's not what's happening. See, the particles of the reactants are getting further apart. Nope, that's not true. When I increase temperature, they're actually colliding more frequently. They're not getting further apart. There you go. Number 9, 100 grams of the same solid are reacting with 200 milliliters of the same liquid in each of the following containers. The molecules are represented by the symbol. So this symbol represents the molecules. Okay? The question should say, in which container will reaction occur faster? Okay, so first thing, anything with a low temperature you're going to get rid of. So you're going to get rid of container 1 and container 2 because they're at 0 degrees. And here, they're more spread out, like if they were a liquid or a gas. And the molecules are more spread out, so they're going to collide. They're tightly packed together, so they're not going to work as good. So the best one, the one you're going to get the fastest, is container 3. Which of the following is true about catalysts in a chemical reaction? Remember I said catalysts are not used up in chemical reactions. They help increase the speed, and they are never changed in a chemical reaction. You can re-extract them. Catalysts increase chemical reaction rates. Okay? Which of the following is an example of a catalyst? An enzyme breaking down starch in your intestine, salt being added to meat to keep it from rotting. See, in here, it's actually stopping the reaction, so there, it's not it. Combining baking soda and vinegar to cause a reaction. They combine just fine with nothing else helping them. Adding heat energy to increase the rate of a chemical reaction. While this may seem like a catalyst, remember I said was a chemical or a compound that we add. So an enzyme helping break down starch in your intestine would be an example of a catalyst. Iron in cars will combine with oxygen in the presence of water to form rust. In northern climates, salt is put on the roads to lower the temperature at which ice will form. Some of the salt is transferred to the cars that drive on the road. This salt, when combined with water and oxygen, increases the rate at which rusting occurs. In the rusting reaction, salt acts as well, it's not a reactant, it's not a product because it's not involved in the reaction. It's just a catalyst, guys. An enzyme is a biological catalyst. That's the difference. Okay? But in general terms, salt is acting like a catalyst that's causing the reaction to occur. Sugar in our body reacts very quickly with oxygen. This same sugar will react very slowly with oxygen and air. The reason for this difference is because, A, our bodies are not warmer than air. Guys, we live in Vegas. This one should be kind of obvious here. Our bodies are not warmer than air. Cells contain catalysts. This is a possibility, and based off what we know, that might be true. The sugar exposed to our air in solid form, last time I checked, most of the sugar we take in is in solid form. The sugar in our cell contains more energy. And remember, guys, sugar can't have any more energy, whether it's in our body or out in the air. So the correct answer is that our cells contain catalysts which speed up the reaction. In industry, speeding up a chemical reaction can mean making a new product faster. Heating a reaction can increase the rate at which it occurs, but this method is expensive. Which of the following may be a less expensive way to increase the chemical reaction? If I have more of it, do you think it's really going to make it occur faster? No. If I have less, no. We're still having to remake it. Do we use a larger container? No. If we use a catalyst, there you go. Because you know what? I can re-extract that catalyst and use it again. Okay? A catalyst is a substance that changes the rate at which a chemical reaction occurs without itself being changed by the reaction. Enzymes are biological catalysts. Which of the following predictions is most likely true of an enzyme in our digestive system? A, the enzyme will increase the rate of a digestive process. Well, isn't this what it says? Yeah, it is. Those chances are. That's what the answer is. The enzyme will decrease. Wait a minute. An enzyme is a biological catalyst. So no, it's not going to decrease. The enzyme will increase. No, because you have to be able to, you'd be taking in more food. It's still going to break down the same amount of food, however much you take in. The enzyme will decrease them. No, it's not. The enzyme is going to increase the rate of the digestive process. Because what is it? It's a catalyst. Thanks, guys. I hope this helped. Remember to study hard.